Before we work through problem number 14, I want to take a moment to review the conjugate pairs theorem. This theorem states that if a complex number a plus bi is a zero of a polynomial, then its conjugate a minus bi is also a zero. So this means that if you're working through, and you see this happen with your quadratic equations when you use the quadratic formula a lot of times, but if you know that, let's say 2 plus 3i is an answer to an equation like we see in these choices, A, B, C, and D. If I know that 2 plus 3i is a zero, then 2 minus 3i also will always be a zero as well. Okay, so that's the conjugate pairs theorem. Now to do a problem like number 14, we're asked to find a third degree polynomial equation with rational coefficients that has roots -3 and 4 plus I. By the conjugate pairs theorem, I know that if 4 plus I is a root, then 4 minus I is also a root. Okay, so I'm trying to get a third degree polynomial. I need it to have x to the third power, so that means it should have 3 different zeros or 3 different answers when I'm finished, and I can see that's coming from these 3 values now. So I can set this up. If I have a root of -3, that means I have a factor of x plus 3. And then a factor of 4, or a root of 4 plus I means I'm going to have a factor of x minus 4 plus I. And then this one means I'm going to have a factor of x minus 4 minus I. All right, so let's set that up, and so we can solve it. So we want to solve x plus 3 times x minus parentheses 4 plus I times x minus parentheses 4 minus I equals 0. All right, so I'm going to let x plus 3 sit out here first, and I'm going to concentrate on these 2 pieces. I'm going to first distribute the negative in both of them to eliminate the extra set of parentheses. So just bring the x plus 3 down, and I'll have x minus 4 minus I times x minus 4 plus I. Okay? Then, this is where it gets a little tricky. Looking at, I've got x minus 4 minus I, x minus 4 plus I. If you look at this long enough, you might recognize that if you put parentheses around the x minus 4, what's left, these are actually conjugates. They're also, because they're conjugates, they are the difference of squares formula. Because remember your difference of squares formula, if you've got a squared minus b squared, that's a plus b times a minus b. Okay? What we have here is this side of that. So that means that this can be factored, or excuse me, this can be expanded using the difference of squares. Rather than having to FOIL it all out, we can just write it as x minus 4 square minus, and then b square would be the I square. Okay, so if you're not following along, discuss it or come let me know if you need help with that. Okay, but that's how we can do this type of a problem, just knowing what we know about difference of squares. Once we've got that, we just need to simplify here and distribute. So we'll still bring down the x plus 3. All right, here we've got x minus 4 times x minus 4 minus I square I know is -1, so substitute that in. And then I've got a FOIL here, that's x squared minus 4x minus 4x, so minus 8x plus 16 plus 1. Now I have x plus 3 times x squared minus 8x plus 17 equals 0. Now I multiply the binomial with the trinomial, so we're going to break the first one apart, making sure we multiply everything in here by each of these terms. So x parentheses x squared minus 8x plus 17 plus 3 parentheses x squared minus 8x plus 17 equals 0. And then distribute this x to the third minus 8x squared plus 17x plus 3x squared minus 24x plus, and I need 3 times 17, which I don't know, 51 equals 0. And then combine like terms. So I have x to the third minus 5x squared. 17x minus 24x gives me negative 7x plus 51 equal 0. So let's see if we can find that choice. Okay, looks like it's going to be C. X to the third minus 5x squared minus 7x plus 51 equals 0. So my answer is C.